So now we're going to pick up with the last part of the graphing idea, which is if you can look at a graph and figure out what the equation is that produced that graph. And I have some kind of a curve here, right? It's going up, down, up, and so on. It's obviously a sinusoidal, but we need to figure out, is it a sine equation, is it a cosine equation, and what all the bits are of that, and make the actual function. Okay, so when I look at these things, I try to establish whether it's cosine or sine right at the beginning. And then I draw a graphing window about it. So I think this is a cosine function. You can see it's like there's a graphing window right here. And that's one full cycle that I just outlined. And then we say, well, what's the length of this cycle? How far does it go in the x direction? Where does it start? How high is it? These sorts of things. So sometimes it's easier to start with midline, because that's just in the middle of the box. See, midline cuts right through here at y equals 3. So there you go. We say y equals 3. And the amplitude. How high up does it go from the midline? How far down? Well, you can see that's 2 units. So we would say that the amplitude of this one equals 2. Okay, now back to the period of the function. That is the distance between its starting point and its ending point, which in our case is 4 pi over 3. It's very easy to look at the right edge and say that's the period in this case, because the left edge starts at 0. Be careful about this point. The left edge of your box will not always start at 0. For now, it does. And we would say the phase shift equals the left edge. That's 0. The right edge is not the period, because the period is simply the width of this box. So if we were starting the box at someplace not 0, you would have to account for that by giving not the value where it ends, but the ending point minus the beginning point. Okay, and we will have plenty of examples later on where the phase shift is not 0, and we can practice that one. So in this case, the period is 4 pi over 3. That's how wide our box is. And most of these things are very useful. Like, see that amplitude? That's A. This equation of the midline, that's K. And the phase shift, that's H. And these are all going to go into a big equation. Remember, I think this is what did we say? This is a cosine function? Okay. We said this is a cosine function. And you see where all these variables are fitting in here. Okay, plus K. We've got our A over here. So I know A, H, and K. I just need to figure out B. I don't know B yet, but I do know that the period is we have 4 pi over 3. And that is equal to 2 pi over B. That's the period equation. So we need to solve this guy. And once we solve it, we get B. Let's go through that quickly. It won't take too long. Cross multiply and we get 4 pi B equals 6 pi, right? I just multiplied the 3 up here and the B over here. Okay, so now, once that's done, we're going to say, we're going to divide each side by pi, and I get 4b equals 6, and then divide each side by 4, and I get b equals 6/4, which you can say 6/4, or you can reduce it to 3/2. It does not matter. So let's plug all these things in here. I've got my b value, my a value, k value, and h value. Okay, those all come in here, and we're going to put those into an equation. And I'll just write the equation down here because I don't have enough room in that box. You would say amplitude to cosine. Don't go away yet. We're not done. 3/2 is b. You can say x minus 0 if you want, or you can just write x. I think I'll keep it simple and just say x. And then plus k. What's our k again? Oh, yeah, k is 3. Now, why am I not done? Because if you take a look at this thing, you have to make sure that we're talking about a positive function and not a negative function. Remember that the amplitude is always going to be a positive number. Well, you have to double check and make sure we don't have a vertical reflection going on here. In this case, I don't. This is a positive cosine function. But in another case, let's say we had a function that went like this. Okay, see how I just drew the negative version? In this case, your amplitude would still be 2, but you would have to do a negative sign in there if it started at the lower bound instead of the upper bound vertically. Okay. In our case, it's a positive cosine. So we really can just say 2 cosine blah, blah, blah. Okay, and that's how you do this thing. These sort of graphing techniques do actually come in handy in a bunch of engineering applications, and I can't resist mentioning one of them. Anytime you get into optics, you're going to use a lot of cosine functions. And if you look closely at my screen, this photo that I took here, see all these wavy lines? These wavy lines on the screen? That is a result of interactions between the camera that I used on my iPad to take a picture of the computer screen where the image was displayed. And those wavy lines actually tell us something about the speed of the cameras, the speed of the screen display, the position between them. It's very complicated, but you can see trigonometry is almost unavoidable if you're dealing with any kind of electronics. It's very cool stuff.